Hello everyone, can you hear me well? Alright, thank you for the confirmation. We'll get started in a minute. Let me just open my presentation. Uh, I hope you all can see my screen too. So today we will start with uh, logical volume management. So let me ask you this first. So did you guys get a chance to go through the previous topics that we have covered so far? Do you have any questions for me? So how comfortable are you with the topics that we have covered so far? All right, perfect. So like, he's saying that he's clear with the primary and extended partition. Well, we have also covered swap partition concept, which is also related to partition creation. What about swap? All right. So let's get started. So today we will see the last topic with respect to the partition. Alright, so logical volume management, LVM. So you would also find when you choose the default mode of installation in your system. So if you don't choose for the customized partitioning, the operating system will default. So there are some advantages of LVMs, so logical volume managers. So I hope you are all following my screen. So here LVMs would allow you to have storage pools. See, by the time you finish creating LVMs, right, you would feel that it is it is same as uh, creation of primary or the extended partition. It is just that we'll be using a different set of functions in creating them. Okay, so I'm sure you would have that feeling. And other than that, functionality wise, there are some advantages of LVMs. So that is something which is the next generation of primary or the extended partitions. So this primarily, so there are certain things which we cannot achieve using the normal partitions like primary or the extended ones, but those features are available with the LVM concepts. So just I'll give you one example, and for the rest of the use cases I'll just go through the slides. Okay, so one example is, say you have a partition, okay, a primary or an extended partition that you have created, which is of 100 MB in size. So as the partition is getting filled up, you felt that you have to increase the size of the partition, but the only option that we have is create a bigger partition, move the entire data from this partition to the other partition, and format this partition. So that is the only possibility that we have. Whereas with LVMs, what we can do is, when you need additional space, okay, in an existing partition, we can increase the space of that partition. We can increase the size of that partition. So that is the advantage. Similarly, say for example, you are using a partition, okay, and you are using very less space in that partition. The rest of the space is just lying idle over there. And at the same time, there is another partition where you are running out of space. So rather than getting space from outside, what you can do is you can do an efficient utilization of your resources by just moving the space from one partition to another partition. So in one partition we can reduce, and then whatever you have saved, you can move it to the other partition. Okay, so such kind of things are pretty much feasible with LVMs. So like that, there are also other advantages of using LVMs. Okay, so with this we will get started. So some of the examples include, as I've said, flexible capacity. The disks and partitions can be aggregated into a single volume, which means, say for example, you are using a hard disk. Okay, so when you're using a hard disk, we all know that we can break the hard disk. So we can split the disk into multiple partitions, right? Say we have almost reached uh, to 95% of the consumption of the hard disk. So again, we have the advantage of adding a new hard disk. Okay, add another disk to the existing system and make that new disk part of the existing LVM group. That means we can combine both the disks, okay, and make it as a single container. Okay, so imagine this. So initially there is a box that represents your existing disk. Okay, and we bought another disk from outside, and you have added that disk to the existing box. So the size of the box has increased. So inside the box we have small boxes, which are our LVM partitions. Okay, so by the end of the day, it could be 3 or 4 partitions that have been combined to create the box, or it can be 2 or 3 hard disks which are combined to create a common container or a common box. So inside the common box, again we will have small boxes that represent the logical volumes. So logical volumes or logical LVMs. Okay, so these logical volumes, again they represent, each logical volume represents one partition. Okay, so so the entire LVM concept is around creating that outer box. Okay, so we call them as groups. Okay, and then creating the converting them. In fact, we convert the physical partitions or the raw partitions to logical volumes first. So we convert them into logical volume, and it is again converted into the logical group, and from the logical group we again extract or take chunks of logical volumes. So totally there are 3 steps involved. Okay, okay, just 1 second. So the process of creating logical volumes starts in the same way we create the normal partitions in the system. Okay, so we use fdisk command to create the partition. So once the partition is created, like the moment we create the raw partitions in the system. Okay, so using fdisk we open the tool, we choose the free space, we create the partition, and by default the type will be Linux. So we need to change the label to LVM for representation. Once it is changed, we save it, and then we use partprobe command or partx command to update the kernel partition table. Okay, so with this, creation of raw partition is over. The next step is, normally we use mkfs command to create the file system, but with respect to LVMs, what we do is we convert these raw partitions into logical volumes. Okay, so we convert the raw partitions into logical volumes. Again, this logical volume is converted into logical group. So logical group is similar to the box. Okay, so raw partition converted to logical volume. If you have created multiple partitions, so convert them into multiple logical volumes. So 3 partitions, for example, so you converted them into 3 logical volumes. The third step is creating logical group. So that is where you combine these 3 logical volumes to a common box, to a single box. So you're simply combining them and creating a container. Okay, and then the fourth step is, from this container you take chunks of logical volumes. Okay, so once logical volume is created, again the process is same. Write file system to the logical volume, mount it, start storing the data inside it. Okay, so let's start. So First I'll check if there are any entries inside the fdisk fs tab, and also if there are any partitions. Yes, there are. You mount, unmount. So we have enabled ACLs. So I have unmounted that. I removed the entry from the FS tab also. Okay. So now fdisk-l. So we have a lot of partitions here. So I'm deleting each of those. Also, what I want to do is I'm going to delete the partition as well. Remember, I told you that swap is needed only when there is no enough space in your system, enough RAM in your system. So here you can see, wow, the total memory used is 1787 and free memory is only 89. So the cached memory is 1627. Alright, so before moving on, since I have opened this memory statistics, so let me give you a very good example. So here it says that total memory I have configured is, this is in MBs, okay, which is close to 2 GB of memory I have configured, out of which it says 17, almost 80% of my memory is filled and rest is 89 MB. Okay, so mostly when we keep running applications in the system, so these application data will be temporarily stored in your RAM. Okay, temporarily stored in part of your RAM, I would say. So that is called as the cache area. So this cache, you can see, like, this mainly helps you in order to speed up the performance of your read and write operations. It will assume that, so this is the amount of data that you have been frequently accessing. So I'll keep it with myself so that I can give it to you whenever you ask me. So taking the data from me is much faster than retrieving the same data from the disk. Always accessing data from RAM is very faster than accessing data from the disk. That's why it caches the data. Okay, so what we'll do is, so we need to clear this cache. Sometimes we need to check and clear the cache. So the cache gets cleared in two ways. So one way is you restart the system. Another way is we need to run a command in order to clear the cache. Okay, maybe I will quickly, just give me 1 second. Let me, so in fact it is not just one command, but it's 2 or 3 commands that we have to run to clear the cache. Just give me 1 second. Okay, so I just opened one of this page. Here you can see there are 3 different ways in which we can clear those caches. So we need to do echo 3. Okay, so we need to update this number to this file. This number itself, it's an internal representation that it will clear the free page cache entries and inode numbers which are present in the cache memory. Similarly, free entries and inode numbers, and then free page cache only. So if you want to do it separately, just use echo 1, echo 2, echo 3. So we will use this command. Alright, so we'll use this and see how much of cache is cleared. Okay, now we have the output. Okay, you remember that 1700 something, right, was stored in cache. Alright, see now. So previously, you remember, right, almost 80% of the cache memory is filled. Now what we did is, so by redirecting echo space 3 to a file called proc sys vm drop caches. So this number itself represents that clear whatever is present in the cache, just swipe it, delete it. Okay, so it will delete all the pages as well as the inode numbers and other entries present inside this web. So this is one good example, okay, where if you feel some difference in the numbers when compared to the reality. I'm not running any applications on my system. This is very simple instance where I've installed very few packages. I'm not running any GUI applications, nor I'm running any database instances. So there is no possibility of RAM getting filled up till 2 GB of space. That doesn't make sense to me. So then I quickly observed free-m. Here I could see that used space is 17 and corresponding cache has increased to the same level. So I need to clear my cache. So how do I clear my cache? By just running this echo space 3, redirect this number to this. So I also told you alternative way. you restart your system. But if it is a production system, we cannot simply restart. So this is the other way in which we can clear the cache memory. Clear? Perfect. Now, so we all reached to this point because of swap. So as long as you have free space available, so I have free space, lot of free space available. So I don't need my cache, I don't need my swap partition. So that's the reason I have disabled my swap space. Okay, this is again just to show you that it is okay to proceed even without swap partition. And parallelly, when there is a need, you should be able to create swap partition. And this step is very important. It is not just sufficient if you disable the swap memory. And you have to remove the entry inside fstab file. In fact, I would say you remove the entry from fstab and you restart your system. That should do. Okay, because fstab entry itself will enable the swap partition. Okay, so I have not deleted the swap partition yet, but I have disabled the swap partition. So now, so this would help me to have more space. Okay. So let's quickly restart. So meanwhile, tell me how many of you have gone through the password reset process? I mean both CentOS 6 as well as 7. So I have told you, I hope you remember, it is very important step from an exam point of view. How to reset the password in CentOS 6, which is very easy. How do you do it in CentOS 7? Alright, if you have not done that so far, please go through the steps that we have covered and practice 6 as well as in 7. 7 is a little, on that day, I hope you remember, we have remounted the partition. By default it will be mounted in a read-only mode. We mounted it in a read-write mode, and then what else we did? I mean, from the beginning in 6, you simply change the kernel argument, add space 1 or space small s and start. You'll land up in a single user mode whereby simply running password will let you change your password. Whereas for CentOS 7, we have to change the line where it says, where you have to insert slash bin slash sbin slash init, the kernel line, and then you have to boot your system from there. Then you'll end up in a single user mode where you have to remount the file system and then run the password command. Once that is done, you have to run exec slash sbin slash init to boot your system from there. Go through the process, practice that, it is important. So now fdisk. Okay, so for this example, for LVM concept, what I do is usually I will create two partitions. Okay, we will create two raw partitions, convert these raw partitions into logical volumes, and once logical volumes are created, okay, we create a volume group, then we create physical volumes, then write the file system, then mount them and start accessing it. So from there the process is the same, something that you have already seen so far. And here are some more examples of uh, advantages of using LVMs. So you can, with respect to device naming, mirroring volumes, creating snapshots is one of the important, very important use case of LVMs um, that is used these days. I'm trying to change the label from Linux to LVM. And this is the one, 8E. Okay. Says change system type to LVM. Similarly, toggle, I've cross-checked everything, saved. So we are done with the creation of raw partitions. Okay. So I didn't find the corresponding command, so I'm searching for the package and I found it. This is LVM2 star. Alright, so we are done with the package installation. And there were too many. I have got PV create and the corresponding PV change. We will also be using LV create, LV change, and we have some more commands like that start with VG. So just with respect to LVMs, remember these three names. Okay, first one is physical volume, converting physical partitions to physical volumes, PV. So there are one or two commands that start with PV. Then we have volume group. Okay, so we are going to combine these physical volumes and create a volume group. So commands will start with VG. We're not going to use all this. I'll just use VG to create the volume groups. Okay, so starting with VG, then we have logical volumes or the slices taken out of the volume group. So we have LB. Okay, we have a few commands that start with LB, like LB create. All right. So you can see I have I've converted these volumes, okay, to physical volumes. I said PV create, okay. So the reason I have used both these partitions is to tell you that it is possible to do it individually, do it first time, second time do it for the other one, or you can convert at a time. So use PV create and create physical volumes, okay. So PV create is the first command. You are converting the raw partitions. Now we have command called PV display to check the corresponding physical volumes that are created in the system, okay. So when you do PV display, you can see /w SDA3 is a new physical volume of 200 MB in size. /w SDA4 is a new physical volume of 300 MB in size. So we have successfully created two volumes, okay. So this is the first step. This should be 6 or 4. The same way, if you have two hard disks, okay, say SDA1 is one hard disk, SDB is another hard disk. So /WSDA /WSDB, we are converting both of them, okay, and we can create a logical volume group by combining both the disks. Okay, so next step is, so we have verified, so these two commands, right, you will see these commands repeatedly across the three concepts. So PV create, PV display, VG create, VG display, LV create, LV display. Okay, so that way it would be easy for you to remember. So now I'm going to create the volume group. So volume group is like the combination of the two partitions creating a container. Okay, so one partition is of 200 MB in size, another partition is 300 MB in size. So we are going to combine both and create a volume group which is 500 MB in size. So it says volume group, new volume, success created. So combined both, created a container which is, the name of the container is new volume. Okay, here it is displaying all the attributes. So it says read write mode, VG size is the combination 500 MB in size. Okay, so physical extents, PE size means physical extents. It's like the outermost wall of 4 MB in size. Okay, so the next is we are going to take chunks. So this is like creating partitions from that container. Okay, so what we do is LV create and the new volume, -L. So we choose the size of the partition that we want to create. So it's like, so we have 500 MB of container available now. Out of that container, depending upon your requirement, you basically choose what partition that you want to create. Okay, sorry, here -N is, say, I'll just name it as logic 1. Okay, logic V1. So I'm creating a logical volume whose name is logic V1. Okay, and the size is plus 100 MB, and I'm creating it out of the volume group called as new volume created. So there is a volume group of 500 MB in size. I need 100 MB, so I have taken it. Similarly, I would also need another one which is 350 MB in size created. So we have 500 MB, out of which 100 has been given to one logical volume, 350 has been given to another logical volume. So we are done with 450. So we are left with only 50 MB of space inside that volume group. Okay, so let's create another one. So we have created 3 logical volumes. So there is no restriction on the number of logical volumes you can create inside the volume group. So now we have LV display again. So you can see this is the path of the logical volume that is created in your system. So /dev new volume logic v1, and it says the size, and then we have the second one, the corresponding size, the third one. Okay, so with this we are done with the creation of logical volumes. Now writing the file system. So previously /dev SDA 1, 2, 3, so that is the format. Now we have converted them into physical volumes. So the process is /dev, whatever is, when you run LV display, whatever you get, you convert them like that. Okay, so I've written the file system. Let's create a few directories. Done. Test all, the process is pretty much whatever we did before. Same. I've created, I've mounted it, and we can go and save the data. I came to that partition. I've created. You can see the files. Moved out. U mount. That's it. Again mounted. Mounted. Data is back. Now inside, in order to make it permanent, again /dev, new volume, new, what was that? Logic v1 and corresponding mount point lv1, file system ext4, defaults is the permission, and then 1, 2. Now if you want to, so going forward, if you want to enable LVM, ACLs, so here defaults comma ACL. Okay. Similarly, we have another topic that is coming up where we configure quotas, user quota and group quota. So mention that over there. That's it. You remount it. Read the fstab file using mount-a. It will be remounted. The rest of the story is the same. Clear? Any questions so far? Hello everyone, can you hear me? Any questions so far? Now I'm going to use fdisk again. Okay, and let us create, okay, we cannot create new partition, right? Alright, so let me quickly delete the partitions and we'll create extended partitions. So what I'm about to show you next is, so as I mentioned, we have two partitions, we combined, we created a volume group, so everything is fine. So we started making use of it. Say for example, we are running out of space, or so we want to pull some space out of the existing volume group. Okay, so let us take the first scenario. So what we'll do now is we will create a new partition, add that partition to the existing volume group. Okay, and then we will try to increase the size of the volume group as a whole, and then we can also increase the size of the individual logical volumes. The same concept is applicable, I mean vice versa. We can reduce the size of logical volume, take the free space out, and we can give that free space to other logical volumes, or we can take the free space out of the entire volume group. Okay, provided that free space should be equal to the size of the least partition that you have added to the volume group. That means there are three raw partitions, 100 MB, 200 MB, 300 MB. You combined all the three and you created a volume group. Okay, and then out of the volume group, whatever is the logical volumes that you have created. Okay, now if you have extracted some free space out of the existing logical volumes. Okay, so this free space goes to the volume group. So inside that bigger box we have small boxes, there is some free space left. So if you want to remove that free space out of the volume group, then that free space should be at least equal to the partition which is 100 MB in size. Because you are extracting means what? You are going to remove one partition out of the three. And which partition can you remove? It should at least, the free space should be at least equal to 100 MB. If it is equal to 200 MB, then you can remove the 200 MB partition or the 100 MB partition. So that's how it is. Okay, the free space should always be equal to, should always be at least equal to the smallest partition among the existing partitions. So I have created 5, 6, 7. So we'll start with 5 and 6 and then we will add 7. Okay. Let's go through the slides first. So here you can see to the existing volume group, a new partition has been added called /dev SDA7. So first of all, we have to convert the raw partition to a physical volume, and once it is converted, you use VG extend. So far we have seen PV create, PV display. So VG create, VG display. So with VG display, we have a new command called VG extend. Okay. So VG extend. So extend the existing volume group, add the new partition. So this is 7. So then if you check the VG display, the volume group as a whole, the size would have increased by the size of /dev SDA7. So once that is done, we have to first resize the existing logical volume. That means using resize to fs, so slash dev new wall, new logic. Say for example, this is the logical partition. So you resize it, okay, to the size that you are expecting to increase, okay. Then use lv extend command and then increase the size by 50 MB. So then you check lv display. So it would have got increased. So this is the most important one here, you can see. So lv extend is kind of a common command, okay. So no, lv extend, lv reduce is also another command, okay. Use lv reduce and say reduce by 15 MB, 50 MB. So that way we extract the free space from the logical volume. Similarly, we can extend, when you use extend, the free space which is present inside the container will be added to the existing logical volume. And then you can cross check it using lv display command. So starting with PV physical volume, PV display done. 100 MB is 1, 200 MB is 1. Then VG display, there is nothing. VG create using SDA 5 6, sorry, VG create new group. Volume group has been created, which is of 100 plus 200, 300 MB in size. LV create. What was the syntax I missed? Okay. So plus 150 MB. So we have 100, 200, altogether 300 is the free space. So let's use the entire free space. Okay. You already have this. Let's mount slash dev, slash dev new group, new logic 1 to LV1. Okay, we have not written the file system yet. Okay, I've written file system. Successfully mounted it. Done. Now So while checking LB1 and LB2, imagine that, assume that uh, we observed that the file system is full. Okay. So I did check and I could see that there is another free partition called /diff SDA7 available. So what I thought was maybe we can add this partition to the existing volume group. So what I did, first of all, we need to convert this physical partition to a volume group. Convert it. Once you convert it, we need to extend the existing group with SDA7. See, it says the volume group, new group has been successfully extended. So previously we added two partitions, one is 100 MB, another one is 200, totally 300. And this is 300 in size, SDA7. Altogether it should be 600. 612 MB in size. Clear? So this is how we add it. Again, while removing also, what you have to do is you need to check the size of the partitions. Sorry, it is LV display. Okay, check the size 150 MB. I'm sorry, it is the physical volumes that we have to check. These are the raw partitions that have been converted, right? So one is 100, 200, 300. So now what I did is I've increased the size of the volume group by 300 MB. Now what is the total size of the volume group? It is 100 plus 200 plus 300, 600. Okay. So the amount of space that is filled is the first two partitions. That's what we considered, right? 100 plus 200, that is 300 space has been occupied. So we want to increase the space. We added third, and we made it 600. So this additional 300 is still part of the entire group. And what did I tell you regarding extracting the free space from the entire partition? I said you need to have the free space that is equal to the size of the least partition at least. So among all these 300 MB is the least partition, this one. Okay, so since, see, imagine that it's not like this data that we are storing is particularly linked to partition 5 and 6, because those are the two partitions that we have initially added. It doesn't work there. So it is like an imaginary container, okay, which is not linked to a specific partition. Okay, so now in order to prove it, what we can do is VG remove. No, it's not VG remove. Yeah, VG reduce. I'm going to this is VG display. Okay. So we just have to 1 second. Okay. So let me begin from here. First of all, the logical volumes that we have. Okay. So you can see this slide. So from the beginning, we have started like creating physical volumes, creating volume groups, creating logical volumes. Okay. Now we are going to follow the reverse process, like removing the logical volumes, then removing the corresponding volume group, then we will remove the corresponding physical volumes from the system first. Okay, let's finish that first. So LV display, so these are the logical volumes. Now I'm going to do LV remove /dev new group new logic 2. There is some problem. It's not allowing me to now. Slash dev LV1 LV2. Oh, perfect. So they are mounted, so it is not allowing me to remove. So LV remove. You really want to remove active logical volume? Yes. Okay. And then 1. Okay, so LV display, there is nothing. Okay, so then VG remove, new group, PV display. We have 5, 6, 7. So PV remove slash SDA7. I think we can remove it like this, multiple at a time. So this is simple, right? So PV create, PV display, PV extend, PV remove. So the last example that I wanted to show that has failed because I didn't check that the partitions are mounted. So that is how to add a new partition to the existing volume group and remove one of the partition because there is enough space which is equal to size of that partition. So I will show you how to remove that partition as well. Okay. Alright, just maybe you can quickly go through these commands, make a note. So PV create, mention the name of the partition. You can also give multiple arguments. Then VG create, new volume, name of the volume group that you want to create, and the physical volumes that you want to add to that volume group, and then VG display. Okay, LV create space -n new logic. So that is the logical volume that you are creating, and it is of size 15 MB, and you are creating it from a group called new volume. And then you write the file system. Then PV create /dev SDA7. This is to extend the volume group size. So with this, the process is over. Now the data is filled. Now you want to extend it to /dev SDA7. You first of all convert it to a physical volume, and then you use VG extend the existing volume group with this partition. So the size has increased. Check the VG display using VG display. Then resize to FS the new logical volume to the size, and then increase by using LV extend command from 50 MB. So whatever is the size of the existing logical volume, you increase the size by 50 MB. And then, so while reducing the logical volume, so previously we have seen how to increase it. Now if you want to reduce the size, it is recommended to do a file system check using E2FSCK command. Okay, and then resize to FS as usual. Even previously we have seen the same command. Whatever size that you are planning to resize to, and then use LV reduce 50 MB will be taken out of the new logical volume from the volume group as a whole. Okay. And while removing, LV remove, PV remove, VG remove, you need to unmount it first. It's the same as the normal partitions. Unmount them first and then remove those partitions, and you will end up with the raw partitions. Okay, if you want, then you can delete the raw partitions also. Always make sure that those partitions are not physically mounted and there are no corresponding mount points present inside etc fs tab file. So these are, so always just remember one set, then automatically rest you can easily remember. Okay, PV display, PV extend, PV reduce, PV create, PV remove, like that. So that's pretty much from this topic on LVMs. So the next topic that we will cover is about NFS service, network file sharing service. Okay, so before going to that topic, so we'll do that tomorrow. So I just want to talk about exporting system variables in a Linux system. I guess I have not covered this before. That means say when you are installing Java or Oracle software, you need to add, you need to update the path variable, right? Echo $path. So there are some list of paths that are displayed when you run the echo command. So where are these? From where do you get this information? Echo $home, right? I told you about env command that will display all this list of variables. So if you want to add something new, uh, okay, with respect to any software or while running any program, so we basically have to export these variables, make sure that they are available in the system. Okay, so the way you do this is take the same path variable. Okay, so all this information is present in the path variable. So if you want to add a new path, for example, this one /home/Saran. So usually why do you add a new folder? Okay, we'll take a better example. So here in these paths you can see there is a directory called opt mongodb bin. Okay, similarly, say you have installed a new software, okay, and it has a bin folder. Bin, what does bin folder contain? Bin folder contains all the binaries, okay, corresponding to that software. Clear? So that is why when we add that folder to the path variable, so you need not have to provide the path all the time. Take the same example, ls opt mongodb bin. So these are the binaries. So if I want to use a specific command, these are all system commands. Okay, so I need not have to type opt mongodb bin mongod like this. I can directly say mongo press tab. So all these are available because the system will search among the list of paths that are present in the path variable. So that is the reason why we do this exporting of the path variable. Clear? So similarly, when you do, if say this is the new software that I'm trying to, so that is already available. I'm just creating the corresponding folder for our reference. So you understood what the error is. It cannot create a directory because first of all, software folder is not present. So I'm asking for a bin folder under software. So you can also create this in a different way. Use -p. That means I'm asking to create this folder, okay, bin under this and this. But if this itself is not present, -p means create the parent if it is not present. So parent for this is this. Okay, so irrespective of the number of parent folders, if they are missing, use -p. It will create the parent and create the folder that you have asked for. So we are going to add this now. How we are going to add? So basically it is all about exporting. Export path is equal to $path. Path is equal to $path means existing uh, content inside path. Okay, opt software bin. It has been added to the existing set of values. Clear? Now this export which you have done is temporary. If you want to make it permanent, you need to add this inside your bash rc file. Okay, how you do that? Remember this process. This is very important. I'm using double redirection operator. If you use single redirection, it will overwrite your bash rc file. So let's not do this. Okay, I'm going to open. Every user has a bash rc file. Okay, every user's home directory has a bash rc, and here you can see export is equal to the same command is added here. So this is doing permanent change. So whenever your system gets started, it will read this, it will execute this command, and it's similar to enabling a service at the boot time. So it will start the service along with the boot process. Similarly, it will export all the variables at the boot time. So if I restart my system by saving this file, so that path is available by default. Like this, maybe you may want to cross check. These are all hidden files. Okay, so bash rc. So there are multiple files. You can also create them inside bash_profile. You can see path is equal to. So these files, they basically export some of the other variables in the system. Bash rc, bash_profile. Similarly, you have .bash history. It has a history of all the commands that we have used. Okay, rather than opening this file, you can simply run history command to check all the history of the commands that you have used in the system. History. Okay, and there is a variable, system variable called hist file size. You can set a value for that variable, so that value means if you set it as 100 previous commands that you have executed in the system will be stored. Similarly, if you set the hist variable size to 500, 500 will be stored. That is something which you can change. Okay, and what else you have? I am not sure about the logout. I've never used it. Okay, maybe you can cross check. That's not that important. So the adding the path variable example is important. The same process will be followed for adding every path variable in your system. Okay, so this is how you export the variables. It is very important. So with respect to any software or any script that you add, it will pull that from the corresponding path. Okay, that is why it is important. All right, that's pretty much for today's class, everyone. So in tomorrow's class, we'll start with a new server concept, which is NFS server, and then we'll go through some of the other important features and topics related to NFS service. Okay, any questions for the day? All right. Go through this all these commands with respect to LVM. Also try to create uh, some system variables and all. Okay. And let me know if you have any questions in tomorrow's class. All right. So see you in tomorrow's class. Have a good day. Thank you so much for attending the session. Bye bye.